All right, good morning, guys. So this is our agenda today. Um, so we're gonna solve that random circle problem first. Should be this one. All right. Okay. So what are the inputs here? What is it? What you see? Color. Yes, color is one. Right. Yeah, given color. Right. So the word given identifying that. Right. Is a radius an input? Is it input or is it an input or not to our function? Yeah, it's not an input to our function, right? It's we generate inside. Okay, so and you can see that, right? See that I didn't give any words like given, like provided for the radius, right? With a random radius at a random location, right? So that's basically you have to generate those inside in our code. Okay, so and then so we're gonna revisit in detail random module this week, probably sorry next week. So this is how one way of we can generate random um, numbers, right? So we import random modules and then use this function. Okay, so and then it's asked to write another function to do this popping circles, right? So let's go and then write our um, code. I'm going to first copy that code right here, the template. All right, and we'll have to import our. So it's let me first write it over here before I forget. Import um, total, and later on we'll also import random as well. So let me copy the prompt. All right. Oops. All right. All right. All right. So so let's do the continue with the understanding. So input one is color. Okay. All right. So the output is basically for the first function, the output is basically a random circle at a random location, right? Okay. So what does it mean by random circle? Is that the circle has a random radius. Okay. So at random location. Okay. All right. So and then we're gonna basically draw it, right? I mean you can draw it like just randomly draw, go somewhere and draw it, right? So it's as simple as that. Okay. So I'm gonna dump this, right? So basically we're gonna, so the turtle is right here. Okay, so at 0 0, and let's say it's a random location, right? So we have to pick that random point, right? So let's say it's this point. I pick randomly, like 40 40. Okay, so then I have to move here, and then I have to pick a random radius, right? And then with that radius I can draw a circle. So we already have a circle drawing function from turtle, so we don't have to reinvent the wheel there, right? So basically use that function, and then let's say like draw the circle, right? So let's say this radius I got randomly was just 10 pixels. Okay, so and that's all what we have to do. We have to write a function that does just this. Okay, so um okay, so basically, so what we have to do then, so we are right here, right? So looking at east, right? And then we need to go here, and then we cannot draw this line, right? So then we have to lift the tail and then go to this point, right? And then draw the circle. Okay, so this plan is real simple, right? So let's write it down. Okay, so what are the matches here before that? um, the yeah, smiley face one we use circles, right? And also go to, right? So smiley face one is a good match. All right, so let's write our plan. So step one, input color 2, right? What do we have to do? First one, first step, tail up, right? Yeah, tail up. 3, yeah, go to random xi. So basically x comma y. So this is a major step. Okay, so because this we have to clarify more in here. So what we are doing here, right? So 3.1, right? So we have to generate x randomly, generate y random. Okay, so x randomly, and then 3.2 generate y randomly. Okay, all right, so what do we do next then? 3.3, we generated x and y. We now move, right? Go to xy. Tail up is already done, right? So go to x comma y. Okay, all right, so that's step 3. Sorry, and then you're gonna go for step 4. What's step 4? There's one step before that, tail down, right? So all right, step 5, we now draw the circle, right? So draw random circle. So that means what? It also has multiple steps. Generate the radius randomly, right? So okay, radius randomly, and then we actually basically draw it, right? So 5.1, and then 5.2, draw circle. Yeah, draw circle with that random radius. Okay, of random radius, I'm gonna write it. Yeah. All right, and you see that if you end up with this, it's really clear what you have to do, right, in your code. Okay, so strive to get this thing done first. Okay, before jump into, because temptation is to jump to code, right? But this gonna help you. Okay, all right, so now we can actually um, um, uh, use our implementation. Okay, so I'm gonna replace here. So this kind of a I'm sorry, this kind of misleading. This is not pass statement. I said it's in English. Pass your, and this is also not input function, right? Pass your inputs. That's a plural s. Okay, so not input function. Okay, so I'm pretty sure this may have created a confusion, so I apologize. Okay, so just we need to pass our input. That means just color, right? All right, oops. All right, so that's the translation of line 1. Okay, all right, so let's write the rest. So basically what's a good docstring? Basically draws, bring the verb to the front, right? Draws a random circle. Well, I would say draws a circle at with a random radius at random at a random location. Okay, a random location. Okay, all right, so all right, step 2. So we are also going to pass a turtle, right? So I'm going to say, like, Tom, right? So Tom dot up. All right, sorry, thank you. All right, then so basically next step, go to, right? So that means we first need to generate these two randomly, right? So we can actually in this like compound step, we can do it in a single line. Okay, so here's how you do it. Okay, so we need to open, like, import random as well. Okay, module. Okay, and then we're gonna basically tom oops tom dot go to, and its location x comma y. Instead of x, we have random dot rand int, right? And I have given the syntax to you guys, right? So so let's say, like, the location can be like, this is the entire Cartesian coordinate system. So we have negative 200, let's say negative 200, positive 200 on x, and then same for the y. Okay, so that means that range can be, well, if we think a maximum radius of, let's say, 100, then basically we can think of this range negative 100 to positive 100. Okay, okay, and then so the same for the y. This is x, right? Same for the y. Okay, all right. If you want, you can create a variable x and equals random all whole thing. You can do that, but why, right? We don't have to, because there's only one time we need this random value, so we directly pass it. Okay, all right. So this is also another good indicator that this whole thing in coding, what is this whole thing, like, terminology wise? Of course, it's a parameter, right? But there's another name for that. No, it's an expression, right? It's a value, right? So that's an expression. So this is a good revelation that it's function calls are also expressions. So in place you need a value, you can use a function call. Okay, so this is a function call, right? This is the function. It's actually a method because belong to random, but it's actually a function call, the whole thing. So it's an expression, so it's as a value, right? It's actually giving us a random number, right? That's it. So that's that. All right, so then we have to tail down, right? All right, and then basically we are ready to draw a random circle, right? So Tom dot circle, and that's this step, right? So and also here we can directly pass this as well. So let's say circle cannot have a negative radius, right? So let's say it's like 0 to probably Tom. All right, Tom, thanks. Right, so that's basically um, 0 to 100 pixel radius. Okay, all right, and then we have color. I can actually we can add the color as well, right? So probably right here, um, Tom dot begin fill, and then end fill, and then and then basically right here, Tom dot fill color, and that's going to be color, right? All right, okay, so let's try this one out over here. So I'm going to copy paste and change. Now my turtle's name is actually a turtle, so I'm going to have to change it to that, right? Okay, so what do we call these two in here? These two parameters in here, this should be a value as well. Let's say red. What do you call these two parameters? Just a this terminology there. No. They are expressions, but there's a specific name for that in this particular usage. No, I want the actual technical name. Yes, they are expressions. Yeah, we just talk about as such, right? This is a function call, right? So what do we call them? This we have been talking about this for quite a while. That's fine. Anyone? I want to dig it out from you. You guys know this. There are two types, right? So in the definition, we call one name. So in the definition, we call one name for these two, and then in the call, there's another name. That's a hint there. Yeah, these are actual parameters. Oh, the function arguments. Okay, so these are actual parameters, or the other name is function arguments. Here we call them formal parameters, or just plain parameters. It's fine as well. Okay, so these are the in the definition. These are kind of placeholder values, right? These are formal values, formal parameters. Here we have actual things because we are now calling the function. Right, like yeah, we are using the bread machine now. So this is flour and the time we bake. Okay, and here is the recipe. This is the recipe kind of, right, definition. All right, so let's run this and then see how it works. All right, so you got one in red, so it's all, they're all going to be red, right? So if I run again, right, I get a different circle at a different location. Now it's small radius, right? If I run again, I have so this basically the random number generator is working, right? It's actually generating the radius randomly, right? Every time you run it, you get a random value and it goes to a random location and draws it. Okay, all right. So then the next function, right? So what do we have to do, right? So the next basically the prompt says, right, write another function named draw random circles, right? This one is circle, right? So circle, this one is circles, by calling your function 5 times to draw 5 randomly popping circles. So how do we do that? Basically it's simple, right? So we call our function 5 times and that's it, right? So let's write that, right? Def, and this is the name. And in this case, if it's too simple, you don't have to spend time on writing the plan. You can directly write the code. Okay, so which is fine. Yes. Oh, we can, yeah. So, but we haven't learned loop yet, right? So this is all making a case for that. So that's why I'm intentionally doing this, so that you guys get this, the idea of a loop. Okay, why we need a loop. Okay, so that's why. So this is kind of, I mean, you'll say that this is nonsense, and later on, once you learn loop, right? Yeah. Yep. Yep. Yeah. So that's what actually, the people who invented coding first time didn't invent the for loop, right? So they realized, oh wow, this is nonsense. So let's facilitate this. So I kind of want you guys to think like that, right? The first time coder ever. Okay, all right. So basically we're going to call this one 5 times the same way we did it over here, right? So that's all. Okay, so right, so you can actually take input as a color as a parameter, right? So let's say sorry, and then we're gonna replace it over here. Okay, or just leave it as this. It's fine as well. Okay, so and I'm gonna, oh, we need a turtle too, right? So I guess yeah. Okay, so let's say a turtle. All right, and then well here, oh sorry, it should be, let's say a turtle, sorry. Yeah, so I'm gonna name it as turtle here. Yeah, and all right, so this is 5. So let's run this one. Okay, so all right, so I'm gonna block this one, guys. Okay, so and then a turtle, and then the color is going to be, let's say, blue. Okay, all right, so let's try this one now and see how it works. All right, so it's actually drawing a blue color 5 circles, right? And you can see it's random, right? So I mean, this is how actually, the game controllers pick things randomly for you guys. I mean, you may have like played a game and see that the demon appears from a random location, right? Right. So it's random XY, right? And then like this, right? So video games heavily use random number generators because you can make things interesting for the user by using randomness, right? So user doesn't know where it's going to appear, so you have to be vigilant, right? So it's one use case of random numbers, but there are a lot in cryptography. There are a lot of usages in random numbers. Okay, so All right, so how the next question, the improvement is how we can actually make the color also random. Okay, so for that you guys need to explore the turtle module. Okay, so let's Python turtles. Okay, so let's check what they have. Okay, and if you go to maybe right here, we can actually check the um, color control, I think filling. Okay, so it's this one actually, probably right here, infill, begin fill. I think it's the color function that I'm looking for. Yeah, see that right here, right? See the color RGB. So what are RGB? It's red, green, blue values, and these are numerals from 0 to 255. So red is 0 to 255. So right here, right? So there's an example over here, right? So
Oh, that's actually real. Is there a way to like pretty much specify how much RGB is in the screen?
yeah, and in regards to turtle, that's how we do it.
Wow.
Yeah, okay. So you can actually specify your color in terms of numerals like this, not like a string like red, blue. You can give this, like if you give as such, I think 255, 255, 255 is just pure white, right? I think, right? So 000 is pure black. So in between you have other colors, okay?
Well, I'm
So,
saying that is because epilepsy, different RGB patterns affect
oh, okay,
affect
okay.
different.
So these are basically in this color function have several forms. You can see that RGB values, and then they can be well, and you can see they are numbers, right? So that number can be random, and if we put that number randomly, we'll get a random color, right? That's the idea. Okay. All right. So that's what we have. That's the that's what I want you guys to think, right? That's how I want you guys to think. You know, we cannot teach every tiny bit every time, right? You guys should be able to at one point rely on the documentation given by the programming language, right? So and that's what actual engineers does. They don't know everything, right? So they actually go through and then learn and then use it. Okay, so and then that's where I actually pretty adamant that you guys rely on Python's own documentation, not anything else in the internet, because they are all opinions. Okay, all right. So so let's take a let's use this. So we're gonna go back and then we're gonna make the color also random. Okay, so we're gonna write a new function. So I'm gonna just take this one and then take out. Now the color also go on as an input because we are also picking up that inside our code. Okay, so I'm going to name this as 2 circle 2, and then all color also gone. Okay, so instead here, right, so the field color, I'm going to use 3 RGB values randomly. Okay, so red going to be random dot randint from 0 to, so these are the RGB values. Okay, so this is going to be G green, this is going to be blue. So but this should be 0 to 255. Okay, all of them like that. Okay, and you will see that this works. Sometimes it's not as such, because if these numbers, random numbers, are really close, you will not see much of a difference in colors. Okay, and we'll see that. Okay, I think that's it. So I made the color also random. It's this one. Okay, so I'm going to write a new function that does the use this 2. Okay, so this is the circles 2, and I'm gonna use 2, and I'm gonna remove color from here. Okay, and then this, we don't need color here because we are randomly generating it. Okay,
Wouldn't it be 3?
no, because circles 2.
Oh,
This is circle 2. Okay, all right, all right. Oops, why? Okay, let's change that. Okay, all right, let's try the second one then. Okay, circles 2. I don't need a color. Okay, so I'm gonna remove that. Well, yeah, I'm gonna, well, let me undo that, and then yeah, I'm going to do this, and then um, call it. Okay, so remove that. Okay, so let's run this code. I'm gonna, so remember safety check, right? Control A and copy first, and then save it. Okay, all right. Okay, so it works. This sometimes it's actually screw you up. Okay, all right. See that it's actually changed now. Is you are now pretty much you are safe. Okay, let's run it. There's a error in line. Okay. So I think I made a mistake. Close line 96. Let's go there. 96. Oh, this should be circles 2, right? So that's why. There you go. Okay. So and they change colors, right? So, and you can see that some colors are close. Why they are close? We saw it earlier actually. There were a bunch of gray values really close. So why they are close? Because see, we are generating these integers randomly, right? Sometimes it may be 254 and the next one is 253. So they are close colors now, right? So because this is a random integer generator, right? It's from 0 to a random value between 0 to 255. So all three can be really close random values, like 10, 11, 12. Really close to, like, I guess probably, I don't know, like a really whitish gray, really close, right? So that's why. Okay, so there's a way to mitigate that. Okay, and then that I haven't given you, so I'm gonna teach you how to do that right here. Okay, so the one way to fix is actually rand range. Okay, so so it's rand int is this. Rand range basically can take a step value. So write this. Okay, so so let's use rand range. Okay, so um, let's say I'm gonna import random. Right, let's say I want colors, right? Equals random rand range. All right, so my range is 0 to 255. Okay, and then I can give Python a step value. Okay, generate those random in steps of, let's say, 10 color, 10 difference, right? So if I give this way, see what happened, right? So I'm gonna and, like, I think I can, yeah, it's 210 now, right? So I'm gonna rerun. Okay, and then if I check color, see, that's 10 now. So they are not there will not be 11, 12, no. So 20 possible, 30 possible, 40 possible, likewise. So randomly, but with the range of in steps of 10. Okay, so this is the step value. So I think this is easier. I'm gonna just directly run it. Okay, and you can see that, and then See 90, right? There's no in between values, right? They are all intense, right? Okay, so that's basically now there's a if I do so, there's a gap in color, right? So I will see different colors. So what I'm going to do is maybe I can, yeah, I can leave this way. This is fine. I mean, if you submit this, it's totally fine. But I'm going to use rand range and give it like 10 and like this. I'm going to change all of them. Okay. All right. So if we try that now, we'll have distinct color differences. Okay. So and we'll not see really close colors. Okay. All right. There you go, guys. So let me leave it like this. And these are the two codes, the latest code, two latest code. Any questions? Yeah. Yeah. Let's see. Oh, yeah. See, it's you put a dot turtle. That's it should be a underscore turtle, right? Yeah. Okay. All right. So line 48 bad input. Let's see what it is. Line 48. Yeah. So see that it's actually at line 47. You didn't close the bracket. They have to match, right? Yeah. Yeah. There you go. Yep. All right. It's line 65. What is that? It's again. Yeah. It's you have to. It you. Yeah. So you have to. Yeah. Yes.
Mine is saying that there's bad input on 27. I tried many different things here and
Mm-hmm.
like moving the line.
Yeah, but there's a syntax error here, right? This line
Why is
27.
it though?
And if you compare line 35 and 27, that you can see the difference.
Is that
They,
why?
they
Because
both are
like
definition, right? 35 is a function definition of main. 27 is function definition of draw random circle. But there's something missing here that you see over here. What is it? It's a syntax notation that you are missing.
oh, like it should match or
No, name should match, right? Main is main always. But there's a syntax component is missing in here.
the two
And
dots.
yeah, the colon, right?
Okay.
Yeah.
Thank you.
Yeah. All right. So yeah.
Still not present for this.
All right. Pass error, bad input line 65. Let's go 65. Go to this line. I think probably this one is not closed. Yeah. Go to the end. All the way to the. You can click end key.
Oh.
Yeah, it's not closed. Yeah. Still there's. Yeah. So probably. Yeah. So rand int. Yeah. So see that. So let me show you the correct way. It's actually supposed to be that way, like exactly like that. See, should be a close bracket, then comma, right?
Can you scroll all the
Yeah,
way down?
all the to the end.
Random range.
It's good now. Oh, random dot. You actually see how random dot rand int, right? Yeah, and all of them. Yeah. So that's how we actually. So random is the module. That's how we actually access an attribute of a module, right? Dot notation.
What if we just do like the X and Y here?
Yeah, you could.
Yeah?
Yeah, you could put like random, but you have to make it like random range. You have to do that random thing if you want to have it random.
Like if I do it like
Because radius is
Yeah.
almost number.
All right, so let's see.
Oh, this one.
Yeah. Yeah. All right, so let's see. And inch, and then go that way. Yeah. So right here, there's a mistake, right? Oh, hey, this should be you should close this bracket right here.
Where?
Yeah, and then comma, and it has to be like that for the rest.
Ah.
Yeah. See that, right? So, but if you when you use rand range, you can have 3 parameters.
Can you scroll down to see, or where
Call.
screen one?
Yeah.
Screen one.
Yeah. This is screen 1.
Okay. So screen one equals terminal dot screen. So nothing's supposed to be in there.
Hmm?
Nothing's supposed to be in there when we run it.
No, where did you get that? I didn't. Do I have that right? No, right? I think just there, just like that. Yeah. So what is it? Let's read there again. Okay, let's read there again. Line 63. Name turtle is not defined. So you go to the top. Go to the top. All the way to the top. See that you didn't import any of them,
wow.
right? You have to import both random and turtle. Sorry, turtle. Yeah. Okay. So guys, I purposefully didn't give you this time, okay, the import line, okay. So you have to import it.
Also, I'm
Okay.
not reading. I didn't even read the. I'm just clicking. Oh, what am I doing wrong? I didn't read the error, and that's
Yeah.
the problem that I have. I need to start paying attention to the error.
That's okay. We are all getting into that, right? Still okay. 86. What is it? Type error. So the type error means so basically you are using this function take exactly one argument, but you are actually giving two. So let's take a look at that. So this takes one, but you are giving two. Let's go to the definition, right? So this one takes color only one, right? Only one, but you are giving two round down below, right?
Yes. So.
So
Color.
so no. So this one other thing, this should be like this should be I think that the tom, this should be tom, not color. Yeah. So tom, because you pass tom, then go down. So and then in your call, right? So which one is your call? Right here, circles. Yeah, this you are giving actually two, right? But there's only one there, right? So you can remove that color. Yeah.
Yes.
Yep. And then I think yeah.
Yeah, because I copied
Yeah.
exactly what you did.
No,
It's a
see
circle.
what I have there. No, you have
Can you scroll
guys.
down?
My code worked, right? That means I got it right. So this is what I have. Okay.
Alright, hold on. Wait
Okay.
a second.
So this is what I have. See, this is what I have. Just turtle, right?
Equals to a turtle.
Oh no, mine's the one we're editing is 94.95 for mine.
Well, yours going to be different. I don't know. I mean, maybe you have some other lines, right? So I mean, don't go for the line number wise, right? Check what I have. I'm doing, and then you can follow. Okay.
A turtle.
So let's run. Let's run, and it should work now. All right. Let's see. That's more, right? 86 again. 86. Yeah. So remove red there.
Can you zoom out? Can you zoom out so we
Yeah, I
can see
can.
the whole
Yeah.
code?
Line 61. Rand. Yeah. So it's a spelling mistake there. Guys, I mean, I need to move on. Okay, I have a lesson to finish, so I'm gonna post this one. Okay, so don't worry about it. So I can zoom out, but it's still like that. Yeah, still like that. So so don't worry too much getting this one, because this is not the main idea of the course, right? Course is like we have to follow the lesson and finish the lesson. Okay, so I'm gonna post this code, right? So don't worry about that. Okay. Okay. So I don't want to take more than my goal is to finish this in 30-40 minutes. So I'm already behind. Okay, because this is only part of the lesson, not the whole lesson. All right, guys. And again, if you couldn't get this done, don't worry. Like so, you can refer my code when I post, probably sometime this week, if not today. Okay. All right. All right. So you know what I can do is I can just now copy paste this code and then post it, and then I can later edit. All right. So that way you can actually, you guys can, yeah. So I'm gonna just post this, the plain code, and I'll later edit and then complete the submission. Okay. So all right. Yep. What do you want to basically? Yep. No. One. Yeah. So from the main one, pick one. Pick one subtopic.
I've
Yeah.
been so busy that I need to catch up on a lot of work today.
That's fine. I mean, you have time, I guess. Yeah. So the suggested due date is 15. So we have one more week, 1 week for the midterm. Okay. So so basically, yes, I recommend, like, out of those, I recommend a few things, right? One is the analysis, the report. The other one is the GitHub one. Those are good for your career. Yes. Yeah, that's fine. Oh, you basically, we learn it in the class, right? How to attach a file to our assignment, right? That's how we do it. Like, like the PowerPoint slides, you can create a Google slide and then put a link, put the link to your slide. Yeah, yeah. Link also, the you can record and download the file, and then submit that file along with the link to your PowerPoint. So that way I can give you feedback for both, right? Because it's not final, right? I check it, and if it is, if you don't get all 10 points, I give you feedback to improve, and you can resubmit. Okay. Oh, okay. So basically, oh, okay. So there is a discussion for you. I recommend you sit down with me in the office hour, and I can show you entire thing, right? But here's how you can do it. Like, here's what I am doing, right? You can use this, and then do the PowerPoint. This one records the screen. There are many software that can record your screen. So you do your PowerPoint presentation in your laptop, in your desktop, right? Right. You do your PowerPoint in your desktop, and then you record your screen. I'm using OBS Studio. This one is OBS Studio, and you can install. This is a free software, and yeah, OBS Studio. There are more other internet ones as well, like browser-based one tools too. Okay. All right, guys. All right, I publish it. It's in module. Let me check. Module 7. Module 7. It's in module 7. Okay.
Module 7, and that's today's assignment.
The video quiz. Yeah. Okay. So it's actually,
Yeah, and the stuff for today.
it's right here.
Also, try and finish this iBooks. I just gotta sit down and cram.
It's this one. Sorry. Tokens. Yeah. Let me take a look over here. Command F. Yeah. That's right. It's actually at the end of module 6, guys. So I'm gonna move it up. Maybe I can move it. Yeah, I'm gonna move it up. It's at the end of module 6. Did you find it? Okay. Yeah. All right. There you go. This one. Okay. It's in module 6, guys. Okay. So I wish Cybook talk about this topic. So, but I decided you should pay some attention. So token is like a key buzzword in programming. In fact, in AI, the large language models, they use tokenization of your prompt. So they tokenize your prompt to understand your prompt. Okay. So it's kind of similar thing here, but this is in programming though. This is not in AI. Okay. So read this description. It's really short summary, but let's watch. Okay. By the way, I actually asked Google to create this video for me. So using this tool, this is a free tool for faculty these days. So the Notebook LM from Google. So I asked them to create this video for me. Actually, I gave them resources, and from that, it's actually generated this. So yeah, module 6. Yeah. So all right. So let's watch it. Okay. So I need to turn them on this one.
Have you ever stared at a line of code and felt like you were trying to read a completely foreign language? Well, today, we're going to decode it. We're going to break code down into its absolute...
Yeah, I think because I don't know what happened. It's out of, right? Let me take a look, guys.
No tokens.
I don't know what happened. It's probably the settings. Nope. But it should, if I do this, it should go all the way, but it looks like, let me check. Oh no, it's fine, yeah. All right, let's try. Okay.
Have you ever stared at a line of code and felt like you were trying to read a completely foreign language? Well, today, we're going to decode it. We're going to break code down into its absolute smallest parts, and I promise it'll make programming feel way less intimidating. Understanding these little pieces is the secret to figuring out how any code works, and, maybe more importantly, why it sometimes doesn't. So let's get started. Okay, take a look at this. This is a super common line of code you might find in a game, written in Python. At first glance, it seems like one simple command, right? Just set the player's score to 100. And yeah, you're not wrong. But here's the thing. How does the computer see it? It doesn't see one single command. Nope. It sees a bunch of tiny individual pieces. And understanding what those pieces are is the key to, well, understanding how programming languages really work under the hood. And that's where a process called tokenization comes in. It's the very first thing a computer does when it sees your code. It breaks it all down into its smallest, most meaningful parts. Let's take a closer look. Each of these little parts is called a token. You can think of it like this. If a line of code is a sentence, then a token is just a single word or maybe a piece of punctuation. It's the most basic, fundamental unit the computer can actually understand. All right, let's start with our first type of token, keywords. Think of these as the absolute, non-negotiable grammar rules of a programming language. Everything else is built on them. So the crucial point here is that keywords are special. They're protected words. They have a meaning that's already baked into the language, and you can't use them for anything else, like naming your own variables. They're what tell the computer how to structure its logic. And here are some of the big ones you'll see all the time in Python. You've got if and else for making decisions, for and while for doing things over and over again, and def for creating your own functions. These are truly the backbone of your code. Next up, let's talk about identifiers. So if keywords are the language's fixed grammar, identifiers are the custom names we get to create. They're the names we give to our data, our functions, all the stuff we build. But you can't just name them anything you want. There are a few simple rules you've got to follow. An identifier has to start with a letter or an underscore. After that, you can throw in more letters, numbers, or underscores. And of course, you absolutely cannot use a keyword, and most special characters are off limits too. Let's see these rules in action. Player score is totally fine, but player score with a hyphen? Nope, not allowed. Underscore name is good to go, but one's name is invalid because you can't start with a number. And class, well, that's a protected keyword, so that's a big no-no. Getting these rules right will save you so many headaches with error messages, trust me. All right, next on our list, operators and literals. These two token types are like a team. They represent the actions and the actual data in your code. An operator is a symbol that tells the computer to do something. It's like the verb in a sentence. Think addition, subtraction, or assignment. A literal, on the other hand, is the raw data itself, the actual number 100, or the text, hello player. And you'll see these operators everywhere. You have your basic math stuff, like plus and minus, the super important assignment operator, that single equal sign, and then comparison operators for checking if two things are equal or if one is greater than the other. And these are the values that those operators get to play with. Literals come in a few main flavors. An integer is just a whole number. A floating point number is one with a decimal point. And a string is just text, and it's always wrapped in quotes. Okay, our final token type is separators. And just like the name suggests, they separate things. Think of them as the punctuation of your code. They help organize everything and show the computer how to read it correctly. You see these constantly in Python. Parentheses are used for grouping things or for calling functions. Commas separate items in a list. A colon is a heads up that a new, indented block of code is about to start. And the hash symbol, that's your best friend for leaving notes for yourself or other humans because the computer just completely ignores them. So, we've seen all the individual building blocks. Now, let's circle all the way back to that original puzzle we started with and put our new knowledge to the test. Remember this little guy? Player score equals 100. When we first looked at it, it just seemed like one simple command. But now we know better, don't we? We can actually see the individual tokens hiding there in plain sight. And there it is. The computer doesn't see one thing. It sees 3 distinct tokens. Player score is an identifier. That's a name we chose. The equal sign is an operator. It's performing the action of assignment. And 100 is an integer literal, the raw data we're working with. And this is why it matters. When you get a syntax error, it's often the computer telling you it couldn't understand your tokens. It couldn't turn your code into a valid sentence. This quote really sums it all up, doesn't it? Once you stop seeing code as this big, scary block of text and start seeing it as a collection of these simple, distinct tokens, the whole world of programming just starts to click. So, next time you look at a line of code, any code, try to spot the different tokens. You now have the key, the decoder ring, to deconstruct and understand any program out there. So the only question left is, what will you build?
All right. All right, guys, let's go to our lesson today. So we actually, we are starting chapter 6. So I'm gonna, so variables assignments. So basically, so we kind of having to go fast, okay? Because today, the other class, we are starting chapter 7. So we already encountered this topic, right? So variables and assignments. So we can go fast on this one. So I'm gonna, and then basically to create a variable, we use assignment statement, right? So many of you guys saw today an error called name error, right? So the reason is you didn't actually assign a value to the variable you use. So pretty much you didn't define it. So you get a name error, right? Saying that you are using a name that I don't know, I don't have a value to assign it. So I don't know what to use. So Python gives you a name error. So that variable is not defined, okay? So, so we use assignment. Usually we use assignment statement to create a variable or define a variable, okay? and this incrementing operator. So basically, so let me go to this one. All right. So let's say like x equals 10, and then to increment the value of x by 1, so we can actually do this, right? X equals x plus 1. Okay, so if you print the value of x, right, and I will see that it's actually 11, right? Right. So how do we read this, right? So x original value is 10, right? And we basically do this when we do a assignments statement like this. We evaluate the right hand side from left to right, right? So and then take the x value, which is 10 and 1, right? So now it's actually 11. Okay, so let's go back. So this is where you can see that, right? It's not like algebra, right? So if you try to read this algebraically, and this makes you read like in the end 1 equals 0, right? Or 0 equals 1, which is not, right? So the way to read is basically x is and then the x value is pointing to 10, and then we are basically adding 1 to that value. Okay, so all right, so let's go back over here. So we call that process incrementing. Okay, so there are other ways you can do the same with other math operators as well. Okay, so that means you can you can subtract, you can divide, all those math operators you can use with that as well. Okay, so and then there's a short format, so I think we're gonna encounter that later, so we'll go check that at that time. Okay, so let's all right, so well, this is, can go to the identifiers. Okay, all right, so identifiers, we just saw it in the video, right? Okay, there are a set of rules to create one, right? So the identifiers are basically the names that we give when we create things in Python. Okay, so we have been already created variables, right? And what are the other identifiers that we have encountered already? That's an, yeah, that's an identifier, yes, but I want the types. So one is a variable type. We gave it we gave we created variables like a lot already, right? And then we gave names, right? That's an identifier. Okay, name, one other thing that we gave a name to. No, just not specific, like okay, so like in here, right? So in here, so we gave like right here, we go to the bottom, I created this variable. It's actually a screen. Yep. Yeah, so that's also identifier, right? So but it's a variable name, right? So my question is, all right, so all of these are variable names. All right, so we gave it a name, right? Anything else? Did we give it a name? Yeah, function, right? So that's the second one, right? So we gave this name to this function, right? Okay, so the second one. First one, we created variables. We gave name to variables. We gave names to functions. There's another one that we can see here. What is that name? That also has a name. It's visible in this code. What is it? Yeah, what are those? Modules. Modules also have names. Okay, so we already know three things that have names: variables, functions, modules. Okay, there's few more, but in this class, that's all we're gonna see. So basically, they are all identifiers because we are giving that name. What whoever created random modules gave that name random to that module, and not us, right? So 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 modules has names, variables have names, functions have names. Okay, three things we so far learned. Okay, all right. And then there are some criteria that you have to follow naming names. You saw some of those earlier in the video, right? And if you go down, and then this is the style that Python recommends. So PEP8. Okay, so it's basically the style guide that you should follow, right? Style guide means, you know, there's a style that we should write in certain occasions in English, right? So for example, to write a scientific paper, there's a specific style guide given by the journal that authors have to follow, right? We call it the style guide. It's the same for this. This is for the programmers to follow this recommended way of typing your code. Okay, not the syntax, right? It's just a way of writing it. Okay, so that's called the style guide, and this is a really famous one. This is we call actually the PEP8 style guide. There's a kind of similar one from Google as well, which is also good. Okay, all right. So and then basically, and all of these are there as well, right? So and then there are some examples over here, and then this is a less meaningful names. Do not use single letter names for variables, like you may have seen from turtle package, right? Turtle sandbox, right? They use T for turtle. I don't recommend. Okay, so I wonder why they have put there though. Okay, so and then try to be expressive. Okay, because someone else need to read those. All right, and then you cannot use reserved words in variable names. Okay, all right, I'm going to probably we can finish this right here. Okay. All right. So basically an object, pretty much many things in Python, they are objects. Okay, and object represent a value. Okay, right? And then basically when we execute the code, probably like, you know, Python interpreter and then creates it. Okay, so for example in here, right? So this color is an object. So basically it's actually assigned to this value randomly generated, right? So oops, okay, so objects have this process called binding. Okay, so we call it name binding. So basically so what happen is usually, right, in the simplest case, when you assign a variable a value to a variable, and then that at that moment the value gonna get bind to that variable, so we call it name binding. Okay, so all right, so and then this animation shows you how it actually works, and then that also shows, I think probably, let's check. Okay, All right. And then this is basically, this is going to show you how you should actually read that value. Okay. So it's not basically, I mean, you better read it that way, right? So basically, saying that, okay, Bob's salary is pointing to the location that 25,000 stored in the memory. Okay. So the 25,000 is the object stored in the memory, and then it's actually pointing to that location, okay, of that memory. Okay. And then try to read, whenever you see an assignment statement, try to read it this way. Okay. So continue. All right. And you can see that, right? So when we did make this assignment, right, Bob's salary equals Tom's salary. Okay. So now basically Bob's salary also pointing to this value. So that means we saw that this became unused, right? So that we call garbage. Okay. Because nobody in the program using that value, right? So that value is no longer needed. Okay. So there's another program runs within Python interpreter called garbage collector. It's routinely go and check for that um, unusedness. Okay. So and then if it figure out, okay, it's unused, and then basically it's actually delete that and then reclaim that memory. So garbage collection is an optimization strategy used by many modern languages. That's happening in Java. The modern C++ also has a way of garbage collection, and also Python. Okay. All right. All right. And then we do some calculation based on those. Okay. All right. So objects have three properties. Okay. All right. So we know that, right? So if we take just 10, well, the value is 10, right? So we know it has a value. Also, object has a type, right? If it is 10, it's an integer, right? Integer type. So we encountered those already, right? So what is the identity then? So let's forget about Python for now. Let's talk about you as a person. Okay, what determines your identity? Really? Like if I take John Smith, can anyone uniquely identify John Smith? There are probably 1,000 in the United States, right? John Smiths. So name alone wouldn't work.
DNA genetics.
Okay, so let's, yeah, you're right. Okay, so do we have to go that far? Oh, then what? How do we identify a person in the United States? Nope. Yeah, well, I mean, you're right in a way, like fingerprint and then face. But easiest way, I didn't get anyone.
Sound, voice.
Your ID, right? It's your social security number. It's unique, right? So everyone in the United States usually has it, right? So except probably a visitor, right? So the uniquely identifying, yes, driver license, but usually it's the social security number. Okay, so that's the ID. If we take a home in the United States, what is the ID? Address, right? And then there are no duplicate address in the United States, right? So it's your address, right? So then what could be the identity of a variable or object, object? And how do we find that out? All right. Which one? Which function? No, type returns the type, right? So int, string, float. All right, so let's take a look, okay, because we are just going to about to learn that. Okay, so all right, so I'm gonna create a variable. Okay, let's say x equals that's 10 is fine. All right, so now I can print. So we use actually the id function to figure out the id of a variable. Okay, so let's say x, and then also I'm going to use id, and then the id x. Okay, all right. All right, it's actually printed two numbers. One is the x value, right? X value, right? And the other one is the id. So what is this id anyway then? I mean, think about the home address. So this is basically, you can think of it as the location in which the x is stored in the memory. Remember when we learned that, like, the memory cells are arranged sequentially, right? So they are numbered. So each memory cell has an address. Think of it's like, each memory cell has a house. Each house has an address, right? So each memory cell has an address, and this id function returns that. Okay, so now if I do this, okay, I'm going to take y equals 10 as well. Now I'm going to print the id of y as well. Okay, so id, so you can see that name, the two different names, right? So but I'm going to print id y. Let's check that. So what do you see? Both have same ids, right? So what does this mean? They both point into single memory location, right, in which the x is stored, the 10 is stored, right? So if you want to visualize that, this is how you actually should visualize. So I'm going to dump this one. All right, so x is pointing to the location of 10, y also pointing to location of 10. The same. Okay, and that's why I was telling you, try to read assignment statement like this, like it's actually pointing to that value. Okay, all right, so that's one of the reason, like, id is the unique value representing, like, pointing to the value object. Okay, all right, so I think we can stop right here. Yeah, so I'm gonna start from this topic on next week, guys. Okay, so the hope is to finish. Yeah, I think we can finish next Tuesday this module. Okay, all right, so with that, yeah, I'm going to open the today's problem. Oh, one more thing, guys. So to open midterm project, you need to finish this one. But if you are not ready, you can submit this empty and get access to this one. Okay, so that means, even though the module access is restricted, right? You have to finish the top one to come to down one in this particular midterm project. If you want to, you can get a 0 and submit, and then come back later and finish it. Okay, so that means you cannot say, hey, you blocked it and I cannot access. No, you can get the 0 for this one and then get access to the next one, which is the midterm, and then see what what we have. Okay, so the strategy is, I want you guys to do this one. Okay, it's a really good um, assignment from library. Okay, so we're gonna, yeah, this one. So okay, so today we are going to move away from turtles, and this is now a word based problem. Okay, so all right, so let me publish it. So I just published it. Okay, so it's in, let's see, I think it should be in module 7, I guess. Let's see, yeah, it's in module 7. Okay, swap first and last. Okay, it's in module 7. Refresh your module view, swap first and last. So basically you get a number and then you have to swap the two ends. Okay, so yeah, I think so I'm going to show you before one thing, right? So I think you need two operators. Yeah, we didn't cover that topic, right? Yeah, I forgot to. So I'm going to show it over here. You need these two operators. One is the integer. So let me quickly do this exercise, guys. Okay, let's say I want to get the remainder of 10 division by 3. What is the value when I
10 addition to 3, 13.
no remain division? So yeah, 1 is the answer. Remainder, right? So remainder, so 10. So basically yeah, so how do we get that value in programming is the question. So this I'm going to show you how to. Okay, so print print, okay, basically 10, this is the remainder operator. Okay, and 3. Okay, so what I should get? 1, right? Okay, so it's not percentage, it doesn't calculate percentage. Okay, it calculates the remainder of 10 divided by 3. Okay, division by 3. It's still running. Okay, I got 1, right? Okay, so but let's say I want to get the count how many whole 3's in 10. Right, so let's say right, so how do we get that? There's an operator for that. We call that integer division, and that's actually integer division operator. Okay, so basically this is going to give me 3. Okay, so regular division gives me that whole thing, right? So if I try the regular division, right, and it's giving me that never ending number, right? So 3.3333 thing, right? And then this is the whole, how many whole 3's in this. So we call this the integer division operator. So today you need these two operators. Okay, so integer division, it's actually basically gives you the how many whole these things. We call this the divisor, right? In, yeah, in 10. So there are three whole 3's in 10, right? Yeah, so this gives you remainder and this gives you the whole, like, that means integer division, right? So basically you divide and discard all the decimal part, right? That's integer division. You divide and discard the whole decimal part, the and then that gives you that number. Okay, so we call it integers. So you need these two operators in today's problem. Okay, so let's go. Okay, swap first and last.